In section 2, we're going to evaluate and simplify expression. We'll talk about the difference between those two words, the difference between evaluate and simplify. We'll look at some terms that we'll use when we're talking about expressions, and then we'll do a few basic examples. And these should be problems that are pretty simple for you, things that you would have mastered in Algebra 1. So first, let's look at a few terms that we will use describing expressions. So first of all, an expression is not an equation. So if there's something like this where I have 2x squared plus 7x minus 3, this is an expression because there's no equal sign. If this is equal to something, then it's an equation. So an equation is a statement that has an expression on either side. So that's the difference between an expression and an equation. But we're going to look at some of the pieces that we have here. I'm not going to, we'll kind of just work from left to right. So first of all, we have, let's start with the x. So we have the x's here. I wish I had a highlighter. We'll just do this. We have the x's here. The x is called a variable, right? The x is the variable in that expression. So then we have numbers attached to those variables. We have the 2 and we have the 7. Those constants attached to a variable term are called coefficients. So 2 is the coefficient of x squared, and 7 is the coefficient of x. Then we have this minus 3 at the end, and that is just the constant term. No matter what we plug in for x, that term stays the same, so it's constant. There's no variable attached to it, so it's not varying, so it's constant. Okay? And then obviously we have x squared, and that squared is called an exponent, but I think we'll get to that in just a second. So that 2 is an exponent. Okay, but in an expression, we'll often have, and then, yeah, each of these things, so the 2x squared, the 7x, and the minus 3, each of those are a term. So a piece that is separated by addition or subtraction is a term. So 2x squared is a term, 7x is a term, 3, the minus 3, is a term. Within those, you have variables and coefficients. And so one other piece that we'll look at, just again to define some terms, what if we have an exponent or a power? Well, there's two of the terms right there. So here we have 3 to the 4th, which first of all, just a reminder that this means 3 times 3 times 3 times 3. Right, 3 times itself 4 times. The 4 is the exponent. Whoa. Or the power. Okay. It's the exponent, or you could also call it the power because it's 3 to the 4th power. The 3 is the base of that exponent or power. Okay. So we have a base to some power. When we evaluate or simplify expressions or equations, we need to make sure that we follow the order of operations. And so this is, I would assume, something very familiar to you, the phrase PEMDAS. And there's different ways that you might remember what order those come in. I think the main one I remember is please excuse my dear Aunt Sally. But we need to look at what, more specifically, those mean. So this tells us the order that we take care of things in an expression. So the first thing that we would take care of is the P, which stands for parentheses. So first we take care of anything that's inside of a set of parentheses. Okay. After that comes exponents. So exponents are the next step. Following that, we do multiplication. which an exponent is really a specific case of multiplication, right? We're multiplying something a repeated number of times. Then comes division, which we know is it could be rewritten as multiplication, so it makes sense that those come together. After division, we have addition, and then lastly, subtraction. And I've seen posts where people, put a tricky equation up there, something like 1 minus 2 plus 3. And what's the correct way to do that? Well, if we're following PEMDAS blindly, then you would maybe think to do 2 plus 3. And so then we would have, 1 minus 2 plus 3 is 5. And that gets us an answer of -4. But that's not right. At this point, we should work left to right. We should do 1 minus 2, which gets us a -1. And then we still have plus 3, which is 2. By doing the 2 plus 3 and then subtracting that, what you've really done is 1 minus 2 minus 3. Or if we were to rewrite this as 1 plus a -2 plus 3, then that clearly shows that the correct answer should be 2. So just make sure you're careful with order of operations. Another one, let's say we have 3 times 4 squared. Make sure that we do the exponent first. So this would be 3 times 4 squared, which is 16, which gives us 48. You should not do 3 times 4 to get 12, and then square it to get 144. So here are a few examples of evaluating an expression. So typically when you see evaluate, your final answer is going to be a number. Maybe you have something to plug in for the variables, or it's just purely numbers in the expression that you can narrow down to a single number value for your answer. The next slide we'll see simplify. When we simplify something, we might get down to a number answer, but usually simplify is going to have variables in our answer. We're going to combine like terms and still have variables in our answer someplace. So evaluate, we want to end up with a number answer. So if we want to evaluate the first one, which is 2 to the third, well, that's just 2 times 2 times 2, which is 8. So when we evaluate this, we get 8. Second one I threw in here to be a little bit tricky. 3 to the fourth, or sorry, -3 to the fourth. So 3 to the fourth is 3 times 3 times 3 times 3. That's 9 times 9. 9 times 9 is 81. So is this 81, or is it a -81? Take a second to think about it. This would be a -81. There's going to be a difference between a -3 to the fourth and a -3 to the fourth. So this is a -3 to the fourth. So what you really have here is -3 to the fourth. In our order of operations, what comes first? The exponent. So we do 3 to the fourth is 81, and then we have the negative. In this case, we have the parentheses that we would take care of first. So here we have a -3 to the fourth. So this would be -3 times -3 times -3 times -3, which is going to give us a positive 81. So this one would be a positive 81, and the -3 to the fourth is a -81. Then the last one, evaluate 3m squared plus 5m minus 12 when m equals a -4. So that means we plug in -4 for m, and then just crunch that out. It's going to come down to a single value. So -4 squared is 16 times 3 gets us 48, plus 5 times a -4 will actually give us a -20, so we could put -20 minus 12, 48 minus 20, that gets us 28 minus 12, which gets us down to 16. When we simplify, we're looking to just move terms around, combine like terms, get things down to as few terms as possible, and we will still probably have variables in our expression in our final answer. So first we just look to combine like terms. So we have a 15x. Do we have any terms with just an x? We got the negative 20x. So 15 minus 20x gives us a negative 5x. We've got a minus 8y and a plus 15y, so we can combine those terms. So minus 8y plus 15y gets us a positive 7y. And then lastly on its own, we have a minus 3x squared. And we could put these terms any order we want. If we wanted to write it negative 3x squared minus 5x plus 7y, that would be fine as well. But that's as simplified as we can make this expression.